So, what happens when all your squares and your cubes, your two-term polynomials, are all mixed together? How do you approach it? Because that's how you're going to see it on your worksheet. That's how you're going to see it on your assessment. So let's talk about how to approach this. 64 x to the 6th minus 49. So first I ask myself, do I have squares or do I have cubes? Well, 64 is both. Square and a cube. 8 times 8. But it's also 4 times 4 times 4. X to the 6th is both a square and a cube. But 49 is not a cube. It's only a square. So we're going to factor this as a difference of squares. There is no common factor, so I'm going to go right to my parentheses. 8x to the third times 8x to the third, and 7 times 7, and one gets a plus and one gets a minus. And then always ask yourself, can I factor more? And in this particular problem, I cannot. So I'm finished. That's it. Question 2. Is there a common factor? Yes, there is. I can take out a 3. 3 into 3x to the 18th leaves me just the x to the 18th. Minus 3 into 375 is 125. Then I look at my parentheses and I ask myself, do I have squares or cubes? Well, x to the 18th is both. It's a square and it's a cube. So I look at 125. 125 is only a cube. 125 is not a square, so I am going to factor this as a difference of cubes. So my 3 comes down. X to the 18th is x to the 6th times x to the 6th times x to the 6th. 18 divided by 3 minus 125, 5 times 5 times 5. So the cube root, same sign. Then I square the first. So x to the 6th times x to the 6th. Change the sign. Multiply them together. X to the 6th times 5 is 5x to the 6th. And then square the last. 5 times 5 is 25. Always positive. And then you're done. You can't ever factor the cubes again unless you have a special case, which we're not going to worry about. All right, next example. Do I have a common factor? I do not. Do I have squares or cubes? These are all squares, so I'm going to factor it as a difference of squares. So 16x to the 4th, 4x squared times 4x squared. 81 is 9 times 9. 1 gets a plus and 1 gets a minus. Can I factor that further? Yes, I can. This is why it's important to recognize a difference of squares. This one can go further. My first parenthesis comes down, and then the second one breaks up again. 4x squared goes to 2x times 2x. 9 goes to 3 times 3. 1 gets a plus, 1 gets a minus. And can I factor further? No, I'm finished at that point. Excuse me. Again, this is going to be your approach to your worksheet. Looking for that common factor, determining if I have squares or cubes and factoring it as such, and then can I factor more? So, next example. Do I have a common factor? Yes, I can take out an x. My 8 comes down. X into x to the 4th leaves me x to the 3rd. Plus x into x is 1. That 1 is important. And then I look. Do I have squares or cubes? 8 is not a square. 8 is a cube. x to the third is a cube, 1 is a cube, so I'm going to factor these as cubes. So, first thing I do, what multiplied 3 times gives me 8x to the third, or the cube root of 8x to the third, is 2x. Same sign, so plus. The cube root of 1 is 1. Then I square the first, 2x times 2x, 4x squared. Change the sign, minus. Multiply them, 2x times 1 is 2x, and square the last. Always positive, 1 times 1 is 1. Once you factor your cubes, you're not going to be able to go further, so don't even have to ask yourself that question. Okay, my next one. Do I have a common factor? Why, yes I do. I can take out a 2, common to both 50 and 8. They both have x's. One has x to the third, the other x, so I take out an x. And y is common, 1 with y squared, 1 with y to the fourth, so y squared is common. And I divide. 2 into 50 is 25. X into x to the third is x squared. Y squareds cancel. Minus 2 into 8 is 4. X into x cancels. And y squared into y to the fourth leaves me y squared. Then I look at what's left. Do I have squares or cubes? My powers are even. They are not divisible by 3, so these are going to be squares. Check them all. 25 is a square, x squared is a square, 4 is a square, y squared is a square. So I have a difference of squares. 25x squared breaks to 5x times 5x. 4y squared, 2y times 2y. 1 gets a plus, 1 gets a minus. And then can I factor further? No, I cannot. And my last example. Is there a common factor? Yes, I can take out a 2. 2 divided into 32 is 16. Minus 2 into 2 cancels, leaving me x to the fourth. Then I look at my terms and determine that I have both terms are squares. So I'm going to factor this as a difference of squares. So 16 breaks to 4 times 4. X to the fourth breaks to x to the second times x to the second. 1 gets a plus, 1 gets a minus. And then can I factor more? And the answer is yes. The second parentheses is a difference of squares. So my 2 comes down. My 4 plus x squared comes down. And then this one breaks up again. 2 times 2 to get 4, x times x to get x squared. 1 gets a plus, 1 gets a minus. And then can I factor more? And the answer to that is no. So you're finished. Okay? So when you are approaching the questions, you really have to look at what's there and be able to understand the difference between a square and a cube. If you don't know that difference, you're not going to be able to factor them. So you've got to know the difference between a square and a cube. And again, if we go back to our cube little formula thing, you're going to cube root the first, same sign, cube root the second. And then square the first, change the sign, multiply them, square the last. Be able to say that to yourself. Be able to say that to yourself. Cube root of the first, same sign, cube root of the second. And then square the first, change the sign, multiply them, square the last.